So 7.5 is properties of logarithms. We're going to be first relating back to some of those properties of exponents that we did. We introduced them in chapter 5. We revisited them in chapter 6. We're going to revisit them right now, 3 of the important ones that we're going to need anyway. So here are the 3 that I want you to write down and remember. So if you have a base raised to an exponent a times a base raised to another exponent raised to another exponent b, remember the property tells us that we add those 2 exponents together. All right, so that's one of the ones that I want you to remember. The second one is if you have x raised to a divided by x raised to an exponent b, this second property tells you that we subtract, and my new and improved exponent would be a minus b. And then the third one is if you've got an exponent a, and then you're taking that whole quantity and raising it to an exponent b, this third property will tell you that you multiply the exponents together, and your new one will be a times b. So just to revisit those, make sure they're fresh in your mind because we're going to be using those and kind of expanding upon them and creating our properties of logarithms. All right, so here are 3 properties of exponents. Let's take a look at the 3 properties of logarithms. So the product property of logarithms. So just again, so that we have this right here fresh in our mind, this one is created from this one right here. Okay, so remember that a logarithm represents a power. Okay, so I'm going to write down what this product property is, and then we're going to kind of explain it. All right, so it looks like this. If we have log base a of, let's say, x, and then plus log base a of y, my product property tells me that I can take the x and the y and I can multiply them together on the inside like this. Okay, the reason that we're relating it back to this is because remember, logarithms are exponents. And so this is saying if I take the power on a that will give me x and I add it to the power on a that will give me y, that would be like multiplying those 2 pieces together. And that's exactly what I'm doing here, just in reverse. I'm taking a product on a, adding it to a product on b, and then that is the same as just reversing back to multiplication. So I'm going to give you an example underneath. So let's say we have log base 2 of 8 and then plus log base 2 of 4. Okay, so again, these are exponents. This first one represents the exponent on 2 that gives us an answer of 8. And the exponent on 2 that gives us an answer of 8 would be 3, because 2 to the third gives me 8. This one would be the exponent on 2 that gives me an answer of 4. That exponent would be 2, because 2 to the second gives us 4. Okay, so that, of course, comes out to equal 5. What we are now going to check is this side of things. Okay, so check the other side of things and see if this turns out to be the same as this. All right, so let's check that out. Let's see what log base 2 of 8 times 4 is. 8 times 4 is 32. So this is now saying what exponent on 2 gives me an answer of 32, and that would be 5. Okay, so it relates back to that property of exponents, but again, this is saying because 2 to the third and 2 to the second, I would be adding those exponents to get 2 to the fifth. So 2 to the 32nd, 2 raised to the 5th gives me 32. So that is this property right here. So here's one of your properties that we're going to be using, and we're going to look at one example of that right now. So we're going to use this. Log base 5 of 2, we're using that approximation, and we will use that to approximate this value. So log base 5 of 250. All right, so what we're going to do is we're going to take the 250 and expand it out as much as we possibly can, kind of break it out into different pieces. So we are going to take log base 5 of 250, and notice that 250, since they gave us 2, they want us to use that 2. 250 is 2 times, and this breaks down to 125. Okay, so 2 times 25 gives us 250, and then we can break the 125 down. So we have 2 times 125 breaks down to 5 times 5 times 5. Okay, so I took 250, I broke it down into these 4 prime factors. Now I'm going to use this property right here. Because right now I look like this. I'm going to break it down into pieces. So this is log base, oops, that should be a log base 5, not a log base 3. Log base 5 of 2 plus log base 5 of 5 plus log base 5 of 5 plus 1 more log base 5 of 5. All right, so I had 4 numbers on the inside here. It looked like this before. I'm expanding it out right now so that it looks like this. Keep the same base in all of these values, and what I'm doing is taking these 4 numbers and putting them in their separate log expression, just like I have up here. Okay, so they gave me one of these. They gave me log base 5 of 2 is approximately 0.4307. Okay, so now these ones we know from previous sections. Log base 5 of 5 means what exponent on 5 gives me 5, and that would be an exponent of 1. So every single one of these is just 1. So I add these 3 together, 1 plus 1 plus 1 is 3, and then tack on that 0.4307. So that would be my final answer. So what this is saying is what power on 5 gives me an answer of 250, and this would be the approximate power. Okay, so I'll show you. It comes pretty darn close. This would be the power that I could put on 5 to get approximately 250. You see, that's really, really close. And of course, this is all approximation. That's what this means. Quotient property of logarithms, really similar to the quotient property that I had in the previous page. This one says this: if I have log base a of x minus log base a of y, it comes out to be log base a of x over y. Okay, so this is the property that I'm going to be using. Again, it connects really closely back to this property right here. This says if I have an expression divided by another expression, what I can do is just subtract their exponents, and what these logs represent are their exponents. So if I have log of a quotient like this, what I do is subtract the exponent that gives me x minus the exponent that gives me y. Okay, so they're really tightly connected to those properties of exponents. Next example here, we've got pH, hydrogen ions, it's given by this formula right here. Find the amount of hydrogen that has a pH of 5.5. Okay, so what we are going to do is we are going to set up log base 10 of 1 over and then we've got the 5.5 that we can tack right down here. So that H plus, we've got 5.5. I'm sorry, this I'm supposed to be setting it equal to 5.5. So this is H plus, that's what I'm trying to solve for.